Okay, so that's our situation. Our task is to find the two values of k. One of them is going to be probably 9 or 10, somewhere out there. And one of them is going to be negative, yeah, it's negative something bigger than 5 or 6. So how do we work this out? Short answer is we need to work out the equation of the perpendicular bisector, okay, and leaving the k in it. So what do we need for perpendicular bisector? What do we need for a perpendicular bisector? Yeah, before that? Okay, which point is it? The midpoint. So we need the midpoint for starters. What is the midpoint of AB? What's the midpoint of AB? We'll do the y first. What's the midpoint of 1 and negative 4? Yeah, negative 1.5. That's the midpoint. What's the midpoint of 8 and k? Add them together and halve it. That's all the midpoint is.
Yeah, but why did you write it as negative 3 over 2?
Because negative 3 over 2 is negative 1.5.
A plus k over 2. Fractions, so it's easy.
Fractions are better than decimals. 8 plus k over 2 is a good answer. Could we write 8 plus k over 2 any different, sort of more simple? The answer is no, you can't. You can't, because 8 plus k over 2, we don't know what k is, so that's it. We're stuck with that. So our coordinate 8 plus k over 2, comma minus 3 over 2 is the midpoint of A and B, whatever B is. Okay, so if k is our 10, then it's going to be, the midpoint is going to be 18 over 2, which is 9. It's going to be 9, 1.5, which is, or negative 1.5, which is up over here somewhere. There's going to be our midpoint. And there it is. Now, to work out the perpendicular, we need the gradient of AB. What is the gradient of AB? Any ideas? I look at a whole lot of absolutely stunned looking faces like we'd never done this before. What is the gradient of AB? No, we don't. Rise over run for AB. So what is the, or what's the formula we use for gradient? Like y2 minus y1 over x2 minus x1 maybe? That's the rise over the run. Gradient of AB is that take away that, which is 5 or minus 5, depending on which way round you do it. That and that take away that. 8 minus k. Rise over run. Again, we don't know what k is. We don't care at the moment. We just need the gradient. Now, what is the gradient, therefore, of the perpendicular to that gradient? What's the rule? Gradient of the perpendicular to AB is 8 minus k over 5, and we change the sign as well. And what's a slightly more simple way of writing that? Maybe put the negative into the top line. What would you get? It would be the k becomes plus, the 8 becomes minus. So we get that. That's the same. Okay, 8 minus k over 5, k minus 8 is just putting the minus into the top line. So we've got the gradient. We've got the gradient of the perpendicular. We've got the point, which is this guy. We've got the point that it goes through, the line goes through. Now what do we do?
K minus 8 over 5 is the gradient of the bisector, isn't it?
The perpendicular bisector, yeah.
So that's the line that isn't.
It's the gradient of it's the perpendicular that we want that ultimately is going to pass through negative 3. Well, we don't know yet. How could we know that at this point? No. No, I don't know what field of mass that would come under, but it's not this topic. So let's just move on from here. What we've now got the gradient of the perpendicular bisector. We've got the point that it goes through, which is the midpoint. Even though we haven't got them explicitly, we've got them defined in terms of our k's and stuff. What do we do next? The question says the perpendicular bisector goes through -3. So maybe what would be the next step? Anyone? What do we do next? Maybe, for the sake of a lot of dead air here, sounds like, you know, nothing's going on. Maybe we need to form the equation. Yeah. It's begging us to work out what is the equation. Okay, we need the equation of the line. So, what's the equation? Y minus y1 equals mx minus x1. And we've got everything we need to work out the equation. We've got that guy there is our gradient. So let's put that in. K minus 8 divided by 5. X minus. And over here we've got y minus x1, y1 is our midpoint from back here. There's our midpoint, our x1. So we put 8 plus k over 2 in for our x. And we put -3 over 2 for our y. Okay? So 8 plus k over 2 goes here. And a normal merit question would do this, but it wouldn't have that k in the way. It would have a number. So all of these would be nice coordinates and it would be relatively easy. But this is excellence. And the k there is there to make it sort of a bit more damn annoying, which it is. And this is y minus 3 minus -3 over 2 goes here. So this guy here is the equation of the perpendicular line that we want. And, well, y minus negative, yep, just make it plus. So, at this point, we've got the equation of the perpendicular line between A and B for whatever k is. Okay, and we don't know what k is. Could be anything. And at this point, if we didn't know anything extra, we couldn't go any further. That would be it. But we know that this line passes through this point. Because the question told us. So this point, 0, -3, must work for this line because it's on the line. So it has to work. Okay? So if we substitute 0, -3 into this, that's your x, that's your y. So if we put 0 in here, -3 in there, then it has to work because that point is on the line. That's the way it is. They are definitely going to show you. So therefore, -3 plus 3 over 2 equals k plus minus 8 over 5 times by 0 minus 8 plus k over 2. Now, we've substituted the 0 in to where the x is. We've substituted the -3 where the y is.
You know how the equation of the line usually starts with y?
Yep.
What do you do there when there's no y?
Well, there was a y. Now we've substituted a point in. See, what we've done is we've said, here's, well, let's go one step back. If I said, here's point A, here's point B, work out the equation of the perpendicular bisector. You would go, well, the midpoint is what the midpoint is, the gradient is what the gradient is, the perpendicular, and the equation. You'd do those steps in that order. You go midpoint, gradient, perpendicular, equation. And you'd have the equation of the line, okay? Now, since you've got the equation of the line, if you substituted points into your equation, it would tell you points on that line. Okay? You could substitute in x equals 10 and find out what the corresponding coordinate is. You could put x equals -5, whatever you like, into the equation and tell you what's on that line. We've got an equation, this one in the rectangular box up here, and that's our equation, but because we don't know what the actual position of that part B point is, we've got this k guy floating around in here. Okay? But it's still just an equation of a straight line. But we do know that this point 0, -3 is on the line. So what we can do is say, since that's on the line, let's chuck it into the equation. In other words, we'll fire it in as a x and a y combination. And that'll leave us with the k's, which we'll be then able to work out what k has to be for it to work, which is the only way to go. Okay. So as I say, this is I would suggest, as hard as it gets for excellence, but it's relatively consistent. Excellence is always sort of similar to this, all those shortest distance questions. So what we've got to do is solve this thing here. And what's -3 plus 1.5? Minus 1.5. So let's just simplify this for starters. Minus 1.5. On this side, we've got a negative sign there, this negative. So it's negative, and we're going to cancel those out shortly. On the top line, we've got k minus 8, and we've got 8 plus k on the top there. And on the bottom line, we've got a 2 and a 5. And I'm going to leave it as 2 times 5 on the bottom line. Okay, so that's what we've got simplified. This guy here, that guy there, multiplied together. There's your minus sign, which I've put down here. And that's a 2 and that's a 5 on the bottom line, so there it is. Now I'm just going to cancel things that are common. Cancel the minus, cancel the minus, cancel the divided by 2, cancel the divided by 2, just to make it easier. Okay? And what are we left with? A 3 equals k minus 8. And I'm going to write it k plus 8 because it's more convenient to have them both the same. And that's divided by 5. In fact, yeah, I'll put it there. Okay. So I got rid of the 2's on either side. I got rid of the minuses on either side because they obviously cancel. And I've just turned the k plus 8, 8 plus k round, so it's similar to that one. Now that's equal to 15. And what's k plus 8, k minus 8 multiplied together, expanded?
K squared.
Yeah. K squared minus 64. Difference of 2 squares, in fact. I've multiplied both sides by 5. And therefore, k squared equals, add 64 to both sides, and you get, what's that, 79? Therefore, k equals the positive square root of 79 and the negative square root of 79. Whatever that is, which is about 8 point something. Yeah, hell of a mission, yeah, massive question.